All right, everyone, we're back with part two here, talking about Confederacy and overlay networks. In the last one, I think we were just talking about some incentives around overlay network operators and creating the most value for the users of an overlay network. So yeah, I'm here with Samir again. We're talking about Confederacy stuff. Why don't we just pick up where we left off?
Yeah. So again, going back to the overlay, yeah, so like when I talk to Craig, he does mention the efficiency and how Bitcoin's protocol, because before Bitcoin, there's only value to the Bitcoin itself, the coin,
Right.
we call it the UTXOs. It was the protocol that really drove the value for Bitcoin, and the protocol was like the open network. Anybody could be able to run a node, use their hash power, bring in their CPU, GPU, whatever it may be, and be able to run the protocol to make sure that the transactions that's happening within the network are validated, and all basically the basic protocols from on the Bitcoin standpoint. No, and there is certain UTXOs, some form of reward in terms of that, and anybody could earn a reward. It was pretty much a fair system, a competitive yet fair system. Now we would like to apply the same protocol on not the UTXOs, because UTXOs is already taken care of, but rest of the data that is attached to the UTXOs. Like, for example, we were giving example of a name, say just a DNS server, or Paymail, or whatever it may be, like healthcare data. There's the up push transaction before, you could attach like 4 GB data of
Yeah, the
data
push
on
data
a single
force, yeah.
on a single Bitcoin transaction. So imagine like how much value we can generate off of that transaction. Now, Bitcoin miners don't care about the inputs of the four up push transaction, for the value within the up push transaction. That's for the overlay network. The topic of the data that they're concerned about, it's their responsibility. So like names, like just giving an example of the name. If a name already exists in the database, yes, it's valid. If the name doesn't exist, then that's add a new record on and so these kind of things, like in terms of a protocol standpoint, I'm trying to figure out an optimal way to use the same Bitcoin protocol onto the overlay network to start validating other data and make it a much more efficient system like Bitcoin, much more attractive system like Bitcoin,
Yeah.
and so forth. So we were now we were talking about how can we do that, especially on the rewards mechanism. It's the incentive mechanism.
Yeah. So
It's where we're
somebody
kind of strong. Yeah.
So somebody wants to interact, right? Somebody has something they want to do. Maybe they want to communicate with somebody else. They want to register some data using a registry or something like this. And they use UTXOs to do this, right? So there's Bitcoin transaction outputs that contain information that is useful for people to that is useful for people to know, and that synchronizes a particular state. And UTXOs are good at reconciling state because you can't double spend them.
Yep.
So there's some protocol that defines how the UTXOs are set up and organized in a way that allows everybody to stay synchronized and whatnot. And in this context, the overlay network operators implement this protocol, and then somebody interacts with it. And so the overlay network operators also have ways of synchronizing data among themselves using the game theory that we talked about in the previous one. And
Yep.
And the incentives are there. And so in this context, how do people actually encourage new entrants into the particular overlay networks? I guess when we consider this, it would be a question of what value these new entrants are adding, right? So why should somebody new come into this overlay network? What do they have to offer? Perhaps they have a disruptive idea, or maybe an extension to the protocol to make it better. But in order to actually participate, just like with Bitcoin mining, you have to be more efficient than anybody else to profitably find blocks and things, right? Or you have to be able to access energy efficiently. In this context, you have to have the ability to do something related to this overlay network and the users that use it, so that those users are willing to pay you for existing on that network and providing services to them, whether it's a better lookup algorithm. So something like Google could be an overlay network where there's UTXOs for each website, and then we have search results that people sift through and find which UTXOs are relevant to their particular which tokens are relevant to their particular search queries, and then they can use that to follow that graph of transactions back and look at other data on that website, on the metadata graph, or something like this. But we have different contexts for defining value, and that's all dependent on the particular topic, the Confederacy topic in my context that is being used for the particular overlay network and the particular rules applied to that topic. Really, it's federated. It's, Confederacy, the definition of that word is in a group of largely independent states that come together to form an alliance. And in this case, it's largely independent network operators that come together to form an overlay and synchronize data because it's rational for them to do so that they provide a value-added service collectively to the users by the synchronization of data between themselves and sharing of information, the facilitation of user lookups, and also the robustness and the availability and the scalability, right? So things are robust because there are multiple operators. They're highly available. If one goes down, then there are other operators who will be able to replace the data or replace the services that are being rendered. And then they're also scalable because the load is distributed to people synchronize and process data on these overlays, but not everybody has to synchronize and process everything immediately. Queuing systems are possible to ensure that load can be spread out when non-urgent requests come in, or requests that affect only one node and not every node. And that way, not every node is affected by the same outages due to traffic spikes and things like this. These load balancing systems and state synchronization systems are all going to emerge as a result of the incentives that underpin data synchronization. I mean, we think of the incentives that underpin traditional internet service providers, right? So like at the highest level, you have I believe they're called tier 1 networks on the internet, right? That are incentivized to peer with each other mutually, right? So it just makes sense for them to connect because of the incentives, right? Like, for example, if AT&T and Verizon, as two competing internet service providers, decided not to peer with each other and exchange data, then they would need to use some other third-party intermediary when requests from one network need to be routed to the other one. Therefore, to reduce latency and add value for their own customers, it's mutually beneficial for them to peer and to exchange data. And this is the same model of incentives that is applied to these overlay network operators so that they can synchronize and exchange data directly between one another, and they can do so in a way that is economically productive and useful to the people who actually interact with these overlay networks.
I think the SPV part of it, I look at it as a protocol where users own their data, right? So because the simplified payment verification. So the way I'm looking at it is where of course Bitcoin, like they talk about the keys, not your keys, not your coins, but we can say, for example, of course that only applies to the coin itself, like the coin itself, but like
it's really a flawed concept. I think not your keys, not your coins is coming from an era where people believe that the code that governs what can unlock a certain thing is sort of in control of everything. I mean, if we replace this, what about not your keys, not your house, or not your keys, not your car? Well, then, if I have somebody else's keys, does it mean that I have their house and it's mine now? Or if I have someone's car keys, then can I just steal their car and it's everybody's okay with this? I mean, I think that's
it's more to do with the ownership of the ownership of the data. So with SPV, I think the whole concept in Bitcoin is like you own your identity, or you own your data,
Right.
regardless if it's a healthcare data or coins or whatever it
Hmm.
may be. Of course, key just an
It's a
aspect to open.
possession.
Yeah,
Yeah.
it's an to access the system. But from an ownership standpoint, I think that is really a unique concept with with Bitcoin, where like the ownership of the data of
Hmm.
your identity is what would also be a driving factor for these overlay networks to synchronize. Because, like, say for example, if there's a overlay network, overlay node, within the network, say just service providing a service for healthcare data, and they become a uh, selfish service provider, say, thinking, okay, they will take away all the customers that they have and just try to start being siloed. Then they'll start losing their customers, because the customers already own their data, and they have
Hmm.
the capability to move
Well, they'll
away
just
to a
rebroadcast it to other systems.
other node providers, because because it's so efficient with the nodes already synchronized. And as soon as the idea for trying to be a selfless and just trying to move away from the network will automatically start reducing their profit, because the users own their data, right? So
Hmm.
own their identity. So because now as a user, I have the ability to move to a bigger network which already has all of my data already synchronized. I just moving away from this selfish uh, service provider to a bigger service provider who are at much higher level and synchronize and follow the protocol. So I think that is also key in driving this protocol forward. And I think SPV does make so much sense, because I'm looking at SPV from a standpoint where, like, all of the data, all of the transactions that I have done so far within the network is somehow I own it. It could be physically from a like, say, physically owning the data into a wallet, or just an ownership concept with SPV is really key. Like, and be able to tie to the whole network via some kind of Merkle proof, some kind of bridge within the network, and be able
Hmm.
to validate and provide validation to, whenever I do transaction to other people within the network, is really key. Also, I think that needs to be applied on the overlay network, protocol for us, for this system to be more robust.
Yeah. I
Right?
mean,
Yes.
so anybody can broadcast any transaction to any node on the overlay, and it's up to that node whether it wants to receive and admit that UTXO into the topic, and then
Sure.
factor it in for future things. Um, I would say in this context, the particular overlays that people are defining are going to govern the rules by which UTXOs are admitted into particular topics. But generally speaking, I think the aggregate the network operators are going to emerge at some level of consensus about what is an admissible UTXO. In
Yep.
the context of a network operator deciding that they want to be siloed or disconnected from the rest of the network, I think this would economically harm that network
Yep.
operator. And I think the reason for that is because if I know that this person is going to silo, then I don't have an incentive to broadcast to them when I want to be participating in a network which is more valuable to me, where there are federated operators. As
Yep.
a user of that network, or as a person who's making decisions about what makes the most sense in an economically efficient context, I'm going to decide to use the system that is going to be the most economically valuable to my users. And therefore, I'm going to, as an application, for example, choose not to interact with that particular service provider. And in
Yep.
that choice, now that service provider has to synchronize that data from somewhere else. Now that service provider, if he wants to stay relevant, is going to need to pay to interoperate and work with the other node operators. And that's going to cost them. Not only do they not get paid when the data is relayed, they have to pay to learn about the data. And as they move away in terms of network distance, as well as, I guess, distance from the ideals or the philosophy behind the people who are operating the federated network, they're going to need to pay more to compensate for those differences because they need to reconcile the state of their UTXOs in the overlay, and the cost of doing that increases the greater the differences in state that need to be reconciled.
Yeah. So when you talk about pay, is that
Pay
like,
with
because
Bitcoin directly to the other operators of the overlay, like using
okay,
packet pay. On the lower layer, when you synchronize things, you pay directly using
okay,
Bitcoin. So packet pay is a system that allows that to happen. You pay for the requests and responses that you send or provide, and it's a way of exchanging funds with that data.
okay. Because like in the Bitcoin, at least from in the mining network, in the proof of work concept, it just the cost is there's the cost to run a node is bared by the node provider in a hope
Yes.
for getting a reward. Versus directly paying the other nodes, because because what you've described, I think for me, like, and correct me if I'm wrong, but what you've described being having to pay these other nodes that's already running is more of a proof of stake system where you have to pay to be part of the network, versus a proof of work is where you bear the cost of, say, the infrastructure that's readily available, because these other node providers that's already in the network will are open source with the protocol, share what's the method that they're using, what's the protocol, and the only thing that this node provider will have to pay is via the cost that is required to be to sync or to be up to speed to start gaining the reward. So I think there's like two different way to honor, to talk about the pay versus the cost. Right.
Right. I
Yeah.
mean, well, the cost to any miner who is in this context, I don't think proof of stake is the right words to describe what we're doing. I think that the cost for any new miner, even on the base level Bitcoin network, who wants to synchronize, that miner will need to pay the other miners in order to set up contracts for the relay of transactions, as well as to synchronize the initial set of transactions on the UTXO set. And I think the initial set of transaction outputs.
Yeah. Okay.
And the reason why is I'm a small miner, right? Remember I described the multi-leader, multi-follower Steckelberg game in the previous little session was, well, if I'm small, I have to pay the miners so that they relay things to me and listen to me or think I'm important. As I get bigger, then they start paying me. Because now I have things that they want, So if I'm Gorilla Pool and I'm receiving all these transactions and I can relay them, well, I'm going to do that on the Bitcoin network, number one, because I want to avoid orphans. But in this context, on the overlay, well, there's no real sense of blocks and orphans and things. Everything is Merkle proof based. So all the UTXOs that get put into the network are proofs get sent around, and therefore things work that way. But in this context, the node operator will have to pay somebody, and in proof of stake on these cryptocurrencies, I think that's a different concept because it refers to the need for, or the delegation of, deciding about what will be on the blockchain to a particular service provider, which doesn't, which makes money when selected by this random consensus process thing. And I think that's easily manipulated and not secure. In this context, because the network is backed by the security of the UTXO model of Bitcoin itself, which is validated by the miners and proven by the blockchain, all these pieces of data are proven using Merkle proofs. The security of the Bitcoin network still enables the interoperability needed for these systems to exchange value, to exchange value for the cost of, not necessarily freely, but you pay for the value that you get. And if you need to synchronize something, then you have to pay for it because there's a cost associated with providing that service to you. So it's not free because of that. But it is economic. It's economically driven. So rational people will provide these things at rational prices, dictated by the amount of value being provided by particular network operators, and that's how the system scales and works economically.
Yeah, so I have just a tiny bit of a different understanding on that. So like as a node service provider, the you know the resistance or you know the difficulty to be part of the node part of the node service provide to be part of the network as another node service provider should not come from the network itself. The resistance should be or it should be more of a in the hope of a reward that like for example tomorrow there are more transactions and they this which of course the users are going to pay for the service is where the reward is for these new node service provider, because as a service provider you don't want to pay upfront cost because that's gonna that's gonna reduce that's gonna be more of a resistance to build a robust a small world network
It's
where
really just a filter, really. If you think about it, it's a filter to prevent those who are malicious or are not really there for the right reasons from joining the network, and keeping the real players in the small world network while keeping the fake players out, and thus keeping it a small world network. In Bitcoin, there's actually strong resistance to new miners as well, because the new miners will need to pay the cost of synchronizing the UTXOs and preparing to, investing in large ASIC farms and things like this. And in order to overcome that resistance, they would need to pay their investment. They would need to repay their investment by actually providing value. So if you try to join an overlay network, there will be resistance. But if you're actually honest, and if you're doing something useful to the members of that overlay network, and if you're correct in your assessment of your utility to that network, then you'll recuperate those costs and eventually become one of the players that earns money from being a part of the network itself and providing information. Just like internet as well. Like when you have a small ISP, you have to pay a bunch of peering agreements and things. But as your ISP gets bigger and provides more value to more people, there's people that actually want to peer with you, and therefore they pay you, and you become one of the medium or large-sized ISPs that people actually want to peer with or need to peer with in order to access certain network resources and things, efficient routing paths and whatnot. So the same incentives apply for any type of federated network, including the internet itself, the Bitcoin mining network, and now these overlay networks that are powered by Confederacy. So
absolutely.
I
understand the point. Like, of course, the resistance should not come from the network, but rather the
just
cost.
A filter,
the cost. Of course, the new service provider has to bear the cost, which is the work that they would be doing. They being honest, like coming up with an ASIC. Coming up with like in the case of mining, there's coming up with a ASICs or coming up with an infrastructure or whatever it may be. But in an overlay network, maybe it could be some kind of server that provides
whatever, you make a new UI, or you make a new protocol extension, or you make a better searching algorithm, or you do something and you create value. That's really what it comes down to, is we create a network of people that create value and do it properly. And when people exchange and when they do things peer-to-peer, there emerges a system of incentives that actually scales, right? And when people can decide on these protocols and stop changing them and make them set in stone, then it allows for better systems of incentives to happen on top. And I think BSV learned that a long time ago. So I think I should get going here pretty soon, Samir, though.
Absolutely.
So, it was good to talk, though, and I'm grateful that you took the time to learn about this stuff. I hope that as time goes on, more people understand this stuff and start to actually implement overlays properly and use SPV properly and all these other things. But with the projects that you said you've worked on and whatnot, I hope it's useful to consider these things, and we'll I'm sure continue to discuss about overlays and other things in the future.
Sure.
For those watching on YouTube, I'm curious I'm curious what the reactions are going to be. I'm curious, like what what people think of overlays and how they can be used in Bitcoin to achieve certain things, whether it's search engines or chat apps or what have you, and do so in an interoperable way across different applications and wallets and whatnot. One of the things that I'm kind of interested in here is like maybe we could have other people like talk about, like we could have almost like a group that could start where we talk about like, I don't know, different aspects of Bitcoin and like protocols, like not even just Bitcoin protocol, but like there has to be protocols for like apps to talk to wallets and for things like that, right? Because I don't know, like, there's the internet didn't really work very well until there was a protocol for websites to talk to servers, web browsers, and there was web browsers and web servers. And so maybe we need the same thing in Bitcoin, and maybe it would be fun to have different people give their opinions of different aspects of that in the future. So
yeah, I fully agree. I think I like the way I look at it. I'm really optimistic. About things normally, and like with Bitcoin, I'm really positive of the way it's developing. It takes because it's a complete new way of understanding
it's a
versus
long road. It takes
traditional.
time.
Yeah, it's a traditional model of doing businesses and doing like interactions, interoperability. So yeah, I feel like Bitcoin's protocol is the best protocol that I've seen in my entire life. And I applied
I
this
agree. Same here.
not only to money side of things, but like in general. So I think it should be simpler process to just apply to like just an overlay network, just to a DNS server or a web page, how the just a program, anything we could potentially apply the same protocol, just extend different meanings, like you say, different meaning to the same protocol. I think the overlays are just different meanings, and if we can do that, I think you'd be we have a long way to go, but I think I'm really optimistic. I'm really positive about this.
Yeah, I'm excited for the future. So yeah, we'll have to do more of this stuff. Thank you, Samir, for taking the time, and on YouTube, everybody, thank you for watching. So we'll end here, and feel free to leave comments or feedback with any thoughts you have about these topics.